Let's look at question 6. So examine if your findings can be generalized. And question A, draw and paste a residual plot of standardized residuals and predicted value. Do you think your findings achieve homostaticity? And how do you think? This is the question of homostaticity. So we're gonna actually draw the plot for the homostaticity staticity and the normality assumption of residuals, normal distribution of errors. So go to analyze, then regressions, and linear, and we already set all the settings here. So simply we will go plot. We're gonna just edit the plot. So go to plot. Um, let's move um, DRESID. What does this mean? Actually, Z means standardized and RESID means residual. So that means standardized residual, right? So move standardized residual to Y. And then Z PRED, what does this mean? Standardized predicted value. PRED means like predicted value. So this is a standardized predicted value of Y. So we move this to our x-axis. So this is our outcome variable, standardized predicted outcome variable should be in the x-axis, and then standardized residual should go at y-axis. This is to see the homostaticity and then the normality assumptions, normal distributions of errors. We have to look at histogram and then normal probability plots. So, and then continue. And okay. So what we will get from this setting is like this. We have three plots. So we're going to look at the last plot. So we draw the residual plot of standardized residuals and predicted value. So if you look at the x-axis, regression standardized predicted value of what? Y. So we predict the value of Y, the statistics test scores, by using the model, the regression model. And then this is the standardized value of Y, predicted value of Y. What is the Y-axis? Y-axis is a standardized residual. So as Y get larger, is there any systematic um, differences in the variance of the residual? So actually, there will be some differences because of the few data points are apart from the major data points. However, we have to look at the overall trend. So overall, let's look it over here. There is not kind of huge differences in the variance, right? So we could say the homostaticity is achieved because the data points, the variance of data points are constant across predicted value of y. But if the data look like this, residual look like this, when y is small, the variance was small. As y get larger, the variance get larger. If the variance of errors looks like this means homostaticity is not achieved, so your assumption is not met. But in our data, fortunately, the homostaticity was achieved because of the constant variance of errors across the predicted value y. So the assumption of what? Assumption of homostaticity is achieved because the variance in error, the variance in standardized residuals are constant across predicted, a standardized predicted value of y. And then let's look at the second question. Draw and paste the PP plot of residuals. Do you think your finding achieved normality of residuals? How do you think? So we learned what PP plot is before. So we may need to look at both histogram and PP plot as well. So this is a histogram and this is PP plot. PP plot is a probability plot, the cumulative probability plot, right? So, okay, we have two plots like here. So first, even though this part is a little bit off from the normal distribution though, overall, the errors normally distributed, except for this part. But actually, we have to remember that we only have the 33 cases in demo data. And then the normal distributions easily violated in small data as we have a more larger samples then the data easily can be distributed normally. So we have to keep this in mind. Our data is only around approximately 30 cases. And then let's look at, so approximately we could say according to the histogram, our error errors are normally distributed approximately. And then let's look at the normal PP plots of what? Regression standardized residual. This is plotted based on the standardized residual. So observe the cumulative probability. This is observe the cumulative probability line. And then the expected cumulative probability you by the regression model. They are This is 45 degrees. If these two probabilities are exactly same, then the data point should be here, right? If they are exactly same. What does this mean? If the data points, the residuals are on this line, that means your observed data is well aligned with your expected values. What does that mean? Our model works well, right? Then how could we determine that? We have to look at each actual data points are close to this 45 degree line. So there is some kind of deviant data point, though the discrepancy is really minor, and then almost we could say approximately or almost the data points are well aligned on the 45-degree line. So we could say not exact 100% perfectly, however, approximately the normality assumptions can be achieved based on the PP plot. So the assumption, let's look at the assumption of normality in the error variance is approximately achieved because the cumulative probability of what standardized residual by this regression model is well aligned with the cumulative probability of observed um, observed standardized residual. This is expected standardized residual. And then over here, it should be observed standardized residual. This alignment indicates that standardized residuals are normally distributed.